should do on 8. Well, I'm having a hard time hearing you. That's better, yeah. I didn't hear what you said as what was your first.
I don't know how to.
Okay, whenever we have a radical sign in an equation, our goal is to isolate the radical sign. That's the first step. So what can I do to isolate that cube root of x plus 10?
Okay. So you take the cube root of that?
Well, let's isolate it first.
Okay.
How do I isolate it? In other words, right now it's being multiplied by 4, and we're adding 3 to it. So how do we isolate just the radical part?
Subtract 3.
Okay, that's a good start. Turns that into 12. Now what?
Wait. What? Oh.
I'm sorry, what?
I didn't know anything about the 12, so I subtracted it.
Okay, so how am I going to isolate the radical sign? Right now it's being multiplied by minus 4. So what do I need to do? Divide by minus 4? In other words, you always do the opposite of what it's doing. If something is multiplying by minus 4 and we divide it by minus 4, it gets rid of it. Okay, so now I got, since those two cancel, now I have isolated my radical. I'm sorry, the sound is not the best here. What's the next step?
That would be n equals 8.
No.
Oh, you're dividing.
No, I've already divided by minus 4. I've already got minus 3 over there. Can you see this bottom line?
Yeah.
Okay. So how do I get rid of the radical sign?
You, I don't know.
Well, if it was a square root sign, we'd square both sides.
Oh, so you cube both sides.
Yeah. And that leaves x plus 10. See, what we're really looking at here, let's remove the radical sign and write it like this. That is the same thing. This is the same thing as this. Okay? And if I wanted to get rid of that minus, or that 1/3, then all I would have to do is cube that side. When you have double exponentiation, you multiply the exponents. So that would reduce that to x plus 10. So no matter what the exponent is, we can always multiply by something to make it 1. Or in this case, we're going to cube both sides. What's minus 3 cubed? What'd you say?
Negative 27.
Now what's x?
You subtract them from both sides. X equals negative 37.
Okay. And that's how you do problems that have exponents. But notice you did that on this number 7. You had square root, so you squared both sides. And that was the quickest way to eliminate that radical sign. And same thing here. Okay, let's look at number 9. Hold on, let me. Okay, what's the first thing I'm going to do on 9? Now we don't have a radical sign, but we have a fractional exponent, which is kind of the same thing as a radical sign. We want to get that isolated.
Right.
How do I do that?
You subtract 1.
No. What will turn the left side into x plus 9 to the 3/2 power?
Oh, you divide by 1.
Well, yes, although that's not the way I look at it. I look at it as multiplying by 7. In other words, what's happening is this is being divided by 7 right now. That's what 1/7 in front means. So I got to get rid of that 7. So let's multiply both sides by 7. Now, it turns out that that's the same as dividing by 1/7. When you divide by 1/7, you flip and multiply. So dividing by 1/7 was technically correct, but you don't want to look at it like that because it makes it seem harder. The way you want to solve algebra equations is whatever is being done, you want to do the inverse of it. This was being divided by 7, so I want to multiply by 7. This other one was being multiplied by -4. I want to divide by -4. This other one had 3 being added to it, so I want to subtract 3. You just do the inverse of whatever is being done. Okay? All right, so if I multiply both sides by 7, I think that's 243. Huh? 343? Yeah, you're right. Sorry. And that gets rid of that. And what I'm left with is x plus 9 to the 3/2. Now, I have to get rid of the 3/2. How do I do that? How do I get rid of the 3/2 exponent?
Multiply?
No. By what? What would you multiply by?
Or like you distribute it?
No. What you have to do is exponentiate it. You have to exponentiate that whole thing to what power? What power will I exponentiate it to such that it'll turn into 1?
Okay.
What power?
3/2.
No, if I do it to 3/2, I multiply the exponents. It'll turn into 9/4. Remember, whatever I write there, I'm going to solve by multiplying these exponents. So what needs to go there?
I have no idea.
2/3, the reciprocal.
Oh, okay.
See why?
Yeah.
When you multiply 3/2 times 2/3, it's 1.
Right.
Well, if I'm going to exponentiate, it's called exponentiation. If I'm going to exponentiate the left to 2/3, then I got to exponentiate the right to 2/3.
Okay.
Now I've got x plus 9 all by itself on the left. I got rid of the exponent. What is that? What's the method we do for this? How do we solve some number to the 2/3 power? What does it mean to take something to the 2/3 power?
I don't know how to describe it. But
Well, the denominator is the root, and the numerator is what you, in other words, we're going to take the cube root and then square the answer. So when you have a fractional exponent, that's what it means. this x plus 9 to the 3 halves originally, that meant the square root of x plus 9 and that answer cubed. That's what fractional exponents mean. So what's the cube root of 343?
Cube root.
That's 7. Remember we got it by multiplying 7 times 49? So that was 7 times 7 times 7. Okay, so the cube root of 343 is 7, and then we have to square that answer. So that whole thing is equal to 49.
Okay.
So,
and then you subtract 9.
right. In other words, it's a constant process of whittling down. Okay? In number 8, we whittle it down to x. We get rid of the 3, we get rid of the minus 4, we get rid of the cube root sign, and then we get rid of the 10. That's what algebra is all about whittling down until you get a final answer. In other words, until you've narrowed it to x. Okay, here we have f of x equals 3x squared plus x, and we have a different function, g of x equals 2x. So what is f of x plus g of x?
3x squared plus x plus 2x.
Simplify that.
Hold on, I need to write it down.
That is correct, but it's not simplified.
That would be 3x squared plus 3x.
Yeah. What is f of g of x? First of all, show me how I should write that. In other words, I know I'm writing it like this, but what's the next intermediate step which would be helpful in understanding? What should I write inside the parentheses?
Inside the parentheses, you should do 2x.
Yeah, f of g of x is the same as f of 2x because g of x equals 2x.
Right.
Now, how do I solve f of 2x relative to the f function?
Plug in 3x, x squared plus 3x.
So tell me what to write.
So 3x squared.
No. In other words, I'm going to plug in 2x wherever I see x.
Oh, right. Okay, so it'd be 3 times 2.
Give me parentheses if they're needed.
Okay. Parentheses 2. So parentheses squared.
2x squared? Is that what you said?
Yeah.
Okay. Plus what? Plus what?
Plus 2.
Plus 2x.
2x.
Okay. In other words, that's what f of 2x is equal to. And don't ever skip this step. In other words, don't try to do both steps at once. Make sure that you just take whatever's in the parentheses and you plug it in for x in parentheses. Now, I could have put parentheses there, but it's not needed. It is needed here. If I don't put the parentheses in, then I'm not going to get the right number here. Okay, so tell me how to expand this.
That would be 12x squared.
Yeah. Plus 2x. So that is f of, that's fog of x. I don't even like the word fog, to be honest with you. I don't know why people use it. They should just write f of g of x. Okay. Okay, what is f of g of 2?
Yeah, so that'd be 2x, and then plug in that again.
Hold on. Always start from the inside out. What is g of 2? All right, let's go up to the g function. You do know this, Taryn. How do I solve that? Forget the f part. What is g of 2? If g of x is 2x, what is g of 2? Yeah, 4. In other words, whatever, that's the rule. No matter what it is, whatever's in the parentheses, you're going to plug in for x in that function. Okay? So I plug in g of 2 into the g function to get 4. And now I'm not going to write f of g of 2 anymore. I'm going to write f of 4. Okay? So what is f of 4 equal to? Okay. That's 16 times 3, 48 plus 4 equals 52. Always, just if you start from the inside out, you can't go wrong in these things. Don't try to do this whole thing in one step. Figure out what g of 2 is. And once you got a number for g of 2, then it's f of that number. And f of 4 you do in one step. You don't really have to combine these functions at all at any point for any of these three problems. All right, is that all on this page? We didn't have any questions about vertex, domain, and range? Or 4, 5, and 6? Okay, so you're adding exponents? So you, okay, it looks like you've done that. So you add, so 2 to the 4th times x to the 11 thirds. Okay. And then here, did you multiply the 2 thirds times the 1/2? Looks like you did. You got, no. Let's see, you got 5 to the 2 thirds, yeah you did, times x to the 2 sixths. You got that by multiplying 2 thirds times 1/2. And the y was in the denominator, you multiplied that by 2 thirds, that also gave you y squared, okay, that's right. And let's see, this one is 10 times square root 87, good. Okay, should we go to the next page? Starting with 13.
Yeah.
Quite. Here we go. Just a second. Rearrange my page so that I have enough room here. All right. Hold on. Okay. So if v, the maximum safe velocity, is the square root of 3.5 times the radius of curvature of whatever curve you're going on. So the ramp at Quincy and C470 has a diameter of 500 feet. What's the maximum safe velocity for turning on that curve? We're solving for V. So what do we need to know?
You need to know
I'm losing you. I'm not quite hearing you. I don't know if it's you get further away from the speaker. Or,
Can you hear me now?
yeah.
Right. You need to know radius.
Yeah. In other words, for me to figure out what V is, I need to know what R is. Okay. What is R here?
That would be the area of
No. Read the problem. The ramp has a diameter of 500 feet. What's R? What's the radius of curvature? What's the relationship between radius and diameter?
radius of half of diameter.
Okay, so what's the radius here?
The radius is 150.
What's half of 500?
Oh, it's 250.
Okay. So that's what V is right there.
Okay.
Now, what is that? That's 5 times 150. I mean, let's see, that would be 25 times 30. So that would be 5 times root 30. Can root 30 be reduced?
It turns out to be 5.54.
No, that's not, I didn't mean reduced that way. Is root 30 in its simplest format? It is, because root 30 is equal to root 2 times root 5 times root 3, none of which are perfect squares. So I can either write it as one term. In other words, I can't reduce root 30. I could reduce it to the product of 3 smaller roots, but each one of these is prime, so I mean you can't reduce any of those, so you leave it as root 30. That's the answer right there. Unless she specifically said convert it to a number and round to the nearest 10 miles an hour. If they don't say that, then don't ever turn that into a decimal. Not at college algebra, you don't. Okay? I mean, unless she told you to. If you've been asked to turn it into a number, do so. But if you want the most accurate maximum safe velocity, it's 5 root 30. It's not a number. It's 5 root 30. It's more exact than what I would get if I turn it into a number. Okay. How much larger would the diameter have to be for a safe velocity of 40 miles per hour? Well, let's see. We've got V equal 3.5 root 3.5 R. So they want to know what will give us a V of 40. What R would give us a V of 40? How do I solve that equation? Well, I didn't hear you. I'm not hearing you.
Can you hear me now?
Barely.
Can you hear me now?
Yeah.
Okay. So you plug in 250, right?
No. We're solving this equation. I plugged in 40 for V because that's what it says. What kind of diameter would there have to be so that we could safely go 40 miles an hour around that curve? So we got to solve this equation. How do I solve this equation? Okay. And the final step?
Hold on. Sorry. My brain's not working fast enough.
I can't hear.
Can you hear me now?
Yeah. What's the next step to solve for R? Okay. So this is our answer for R, but they didn't ask about R, they asked about diameter. So what do we need to do? What's the relationship between radius and diameter? Okay, so we need to multiply this by 2 to get diameter. In other words, we just solved for R, right? But they want the diameter. So since diameter equals 2 times R, so in a sense you're right, you plug this number in for R. But you don't have to do this. In other words, after you work with diameters and radiuses enough, you know that the radius is half the diameter. So if we just solved for the radius, I got to double it to get the diameter. So the diameter would be 3,200 divided by 3.5, whatever that number is. Okay. That'd be the diameter of the intersect. In other words, you know the loop. At Quincy and C470, there's a loop. So you make sure that the diameter of that loop would be 900 feet. And then you could safely go around that curve at 40 miles an hour. All right. Okay, here we have the height of a dinosaur. Hold on, I'm trying to figure this out. Can be modeled by where L is the length of the dinosaur's instep. So the height as a function of its instep is 3.49 times the length of the instep to the 3/2 power. Okay? Let's write the inverse of this function. How do we get inverses? There's 2 steps to get an inverse. What's the first one? You should always remember these 2 steps. Now, they can be done in either order, but I think it's helpful if you remember them in a particular order. And the order is you switch the variables and solve for y. Okay, well, we don't have a y here. So let's make h of L equal y. And now we can switch the variables and solve for y. Okay? So what's the next line going to read? No. What's the first step in solving for the inverse? When I said switch the variables, I didn't mean switch y with h of L. In other words, once we have the function described like that, now you got to switch the variables and solve for y.
Okay. So then you would do the inverse of the...
Well, first of all, switch the variables. Let's do it one step at a time. First step is always switch the variables. So what do I get when I switch the two variables?
This is really confusing. I don't know.
Okay, what are my two variables in this equation?
L and Y?
Okay, switch them.
Oh, okay. I see what you did. Okay, so the L equals 3.49. Yeah, okay. There we go. Took me long enough.
It's all right. Okay, now the second step of solving for the inverse is now solve this equation for y.
Okay.
How do I solve this equation for y? How do I isolate y? That's the trick in all of these inverse problems, is once you switch the variables, then there's a little bit of algebra you have to apply to solve for y.
So you would set L to 0.
You would what?
You would set L to 0, like make it 0.
Okay. How do I isolate y? I am trying to isolate that. What do I got to get rid of? What two things stand in my way from it being isolated right now?
3.49 is the exponent.
Okay. So how do I get rid of the 3.49?
Subtract it.
What is the 3.49 doing right now?
No, you just divide it.
Okay, because it's multiplying.
Right.
Okay, so if I divide everything by that, I'm going to get rid of the 3.49. Now, I got to just get rid of the exponent. How do I get rid of the exponent? No. You get rid of exponents by another exponentiation. In other words, the only way I can get rid of that 3/2 is by taking this whole right side to another exponent. What is that other exponent have to be? 2/3, exactly. Which means I got to take this to the 2/3. That leaves me with y all by itself. I've solved for the inverse. And this parentheses over here, very important, because you're taking L divided by 3.49 to the 2/3 power. So if you leave the parentheses off, it's not going to be right. Okay? So remember this step. When you need to get rid of an exponent, exponentiate it again to the reciprocal of that exponent. Doesn't matter what this exponent is. If that exponent's 7 divided by 3, then you exponentiate it to 3/7. Okay? All right.
Okay, and then so from the length of the instep,
So if the hip height is 160, we're solving for L. Now, first of all, this has nothing to do with the inverse. These are two separate questions.
right.
Okay? So we're going to go back to the original function. And they want to know what value of L would result in a height of 160. So how can I start with their equation, their original equation that relates height, which is y, to the length of the instep, which is L.
So you would do 160 equals L over
No,
3.
no. We're not working from the inverse function.
Oh, okay. You were working from the original.
Yes. Remember that the inverse function is the inverse function. It's not the same as the original function. Remember, I switched the variables before I solved for the other variable. So that inverse function has nothing to do with this question. This question, you use the original function that related the hip height to the length of the instep. Well, that was this function right here. That's the function that relates hip height, which is the h of L, to the length of the instep, which is L. So if I plug in 160 for the height, I'm going to be able to now solve this equation for L. And that's what they're asking for, is to solve that equation for L. How do I do that?
You want me to start with like the exponent?
What?
Do you like divide first, like 3.49L?
Not by 3.49L.
It's just 3.49.
Yeah, notice that if I divide by 3.49L, what happens to this 3 halves that's sitting out there in space?
It doesn't.
I'm trying to isolate L. I'm trying to solve for L. So my first step is to get rid of everything that is affecting it. It was being multiplied by 3.49, so let's divide by 3.49. Now how do I solve this for L?
Alright, I'm just writing it down as I'm talking.
Okay.
And you do the inverse and you multiply.
Tell me what to do, because I don't understand what you just said.
So you would multiply by 2/3.
It's not called multiplication. I haven't heard you say the word yet. It's exponentiation. Okay? So I would exponentiate both sides to what power? Okay. That's not multiplication there. That's exponentiation. Okay? So that leaves L. We have now isolated and solved for L, and it's equal to whatever that number is. Okay? Okay, let's see. Find the length of the the length of the instep can be modeled by. So now they're giving us a function for the length of the instep. In other words, they're going to say that the length of the instep can actually be modeled by the footprint length. L of P, the length of the instep, is equal to 1.2 times the length of the footprint. So, what is H of L of P?
H equals.
Hold on. Let's write it step by step. What's the first thing? How do I get H of L of P?
H equals.
No. Start from the inside.
Inside out, okay.
What's L of P equal to?
L of P is equal to 1.2 times 1.2.
No, it's equal to 1.2 times P.
Okay.
You see why you can't plug in 1.2 there?
Yes.
Because they don't want a specific footprint. They didn't tell us what the footprint was at all. They just want to know what the hip height is going to be as a function of the footprint instead of the function of the instep. Because we have the instep as a function of the footprint, I can now write the hip height as a function of the footprint. Well, that means that it's H of what?
H of 1.2.
P.
Right, P.
That's L of P right there inside the parentheses is 1.2P. Is all I did was copy it from right there.
Okay, I see that.
Okay, so now our H equation was what our H equation is H of L is 3.49 L to the 3/2. So what would H of 1.2P be?
Okay, so then you would just plug
What's in the inside of the parentheses?
okay, so 1.2p. So then you multiply that
And
with 3.4.
plug it into what?
You plug it in for L.
Okay, so tell me what to write.
Okay, so you do 3.49 parentheses 1.2p to 3/2.
All right, now you got it. That is what H of L of P is equal to.
Okay.
In other words, they didn't want a number. They wanted to know what the hip height was as a function of the footprint, P. In other words, now is all I have to do is give you a footprint length, and you can estimate what the hip height is.
Okay.
Whereas before, to get the hip height, I had to give you a instep length.
Right.
Well, since the instep is a function of the footprint, I can make hip height a function of the footprint.
Okay.
Evaluate H of L of 20.
Okay, so you would plug 20 in for L.
Well, no. Remember, L of P is 1.2 times P.
Oh, so you'd plug...
That's L of P, right?
Mm-hmm.
Okay, so P is 20, not L.
Okay.
So I'm going to plug 20 in for P into this equation right here.
Okay.
You see why? In other words, they're asking me, here's H of L of P, and now they want to know what is H of L of 20. So wherever I see P, I'm going to put 20. Well, I see a P right there. So the next line, H of L of 20 is what? Not a number, but the equation.
So the H equals...
Hold it. Let's just fill it in. Here's our equation for H of L of P
3.49
times
times 1.2
times
times 20.
all raised.
All raised to the 3/2.
Now you can get a number for that. Okay, in other words, we can now get a number for that because they have given us a footprint size of 20. That's a big footprint size, 20 feet, or centimeters maybe, I guess.
And then that'd be 374.58.
I don't really care about these answers. It's setting it up that's important. I'm presuming that between you and your calculator you can come up with a number there. What did you get approximately?
374.58.
Well, let's see. We have 3.49 times 24 to the 3/2 power. Well, 24 to the 3/2 power. Did you do it that way? In other words, you have to take, in order to evaluate this thing in your calculator, you have to multiply the 1.2 times the 20 first.
Oh, okay. That's the mistake I always make. I need to write it out.
Because all you need is to look at the parentheses. You don't need a note. You need to look at the parentheses. The 3/2 is outside this second set of parentheses. The exponent always operates on everything that's inside its parentheses. Well, its parentheses are these. So you have to evaluate the inside first to get 24, and then take 24 to the 3/2, and then multiply it by 3.49.
Okay. And then multiply that and by 3.1. And I got 410.33.
Okay, yeah, I don't know. It's hard for me to approximate what 24 to the 3/2 is. Let's see.
That is 117.5.
All right, that sounds right. And then multiply that by 3.49 and you have your answer.
Right.
All right. Let's look at 15 here.
Okay.
So S equals 258 root D, where S is the speed of the tidal wave and D is the average depth of the water in kilometers. Let's write an inverse function. I'm not sure why they're starting off each of these problems by having you write an inverse function, because we're not using the inverse function after we come up with it.
Right.
Okay, that's all right though. What's the inverse function going to be?
The inverse function is going to be...
What's the first step?
You change the S and the D. So that's 258 square root of S.
Second step?
Sorry, I need to erase it.
What's the second step conceptually? In other words, if the first step is to switch the variables, what's the second step?
You divide by...
No, you solve for S. You solve for S. In other words, you solve for the variable. We had it solved for S. But once we switch the variables, it's never going to be solved for that. So now we have to do algebra on this to solve it for S. So what's the algebra I have to do to solve that for S?
You square both sides.
Not yet.
No?
Always isolate the radical first.
Right, so you subtract. No, you divide. Never mind. 258 on both sides. So it'd be D over 258 equals the square root of S.
Okay, now what?
Then you square both sides.
Okay, so S is equal to D over 258 quantity squared. And there's your inverse function. Now, like I said, part B isn't going to have anything to do with that inverse unless I'm mistaken. I mean, there may be a way to use that inverse to solve for this, but I don't see the reason why we would want to do that. I might be missing something, but you don't need the inverse to solve answer B. If I have a tsunami traveling at 150 kilometers per hour, what is the average depth of the water going to be?
Alright, so then you plug in 150 for S.
Okay, so give me the equation. Yes,
So that's
always into the original.
Equals 258 square root of D. And then you divide by 258.
Maybe they asked the question about inverse because in order to solve these, we're going to do exactly the process we did solving for the inverse. Notice that I divided by 258 and then I squared both sides. Well, that's what I'm going to do here. So the answer is that squared. That is the depth that would give you a speed of 150 kilometers per hour.
Right.
Something's wrong here. What is wrong? We're going to come up with a number less than 1. Uh-huh. Depth is the average depth of the water in kilometers. Oh, okay, that's good. No, we're fine. Kilometers is a lot. That's almost a mile. So coming up with a depth of less than a mile is okay. As long as it's not less than 1 foot, then we'd have a problem.
0.33 equals feet, right?
Like I said, I don't have a calculator to do these. So you did this calculation, you got 0.33? That's 0.33 kilometers, which is probably, let's see, that's about 330 meters. So that's pretty deep. That's about 1,200 feet of ocean. And you can see why tidal waves become so dangerous as they approach the shore. The depth of the ocean goes from 2 miles deep to 20 feet. So as D gets smaller and smaller, S gets faster and faster.
Okay.
So you have a tidal wave that may be moving. No, I got that wrong. As D gets smaller, S gets smaller. There's a direct relationship there. In other words, if I look at this function here, I can say that they are directly related. S is directly related to the square root of D. And remember from our inverse and direct relationships, if something is directly related, then as this variable goes up, this one goes up. As this one goes down, this one goes down. So what this says is that as you get close to shore, the speed goes smaller. But the height of the tidal wave gets bigger.
Right.
Even though they don't really tell us that anywhere here. We wouldn't know that. It's just I know about tsunamis, and I know that as they get close to the shore, that's when they get big waves. If a tsunami is out on the ocean and you're in a ship, you're not even going to see it. It's going to be about a foot wave. But by the time it hits land, it might be 30 feet high.
Yeah.
And I
We
suppose,
did like a whole thing on like tidal waves and
yeah,
stuff.
I suppose the reason it does is because the speed gets less. In other words, if the speed is directly related to the depth, and the depth is getting smaller, the speed, it's slowing down, and apparently as it slows down, it must increase the height of the wave.
Yeah, the energy or like the speed of the wave slows down as it approaches land.
Okay.
So the height increases and the velocity increases.
Yeah. Okay. All right. Is that all of them?
Yes, that's all I have today.
Okay. So let's.
Perfect. Thank you.
You're welcome. Let's see. We're on for next Monday at 5.
Correct.
That'll be your last session for a while, I imagine, huh?
Yeah, sounds about right.
In fact, hold on a second. I got it wrong here. I got you down for the 15th, but you won't need the session on the 22nd, correct?
Correct.
You're
On the 22nd.
right. You're out of school by then. Okay.
Right.
So let me cancel that one. And then, do we know when you pick back up? When do you get back on school?
Ooh, not exactly sure. I can pull it up really quickly.
You probably, I'll bet your first day back in school is that Monday, January 5th.
I got the calendar right here.
And I don't know if you'll need a session that day or not.
I don't think I will, just because it's the first day back.
Right. Okay. Let me go ahead and take you off of that day. And then if something comes up that day, call me. I usually have spots open on Monday on a moment's notice. So if you end up with some work you need to do that day, let me know.
All right. Sounds good. Thank you so much.
All right. I will talk to you next Monday night.
All right.
Bye-bye.